So yeah, my name is Fedor. As David said, and I'm going to share a little bit of a story of how we built a system to avoid model drift, or data drift actually. Not all of the data drifts, but some of them. And we did it with a human loop because actually that's part of Toloka heritage, and Toloka is where I work now. And I think I'd like to probably start with asking you how many of you have implemented any human loop pipelines before, somehow combined humans and machines. Right, 1, 2. Oh, and it's not bad. Okay, some people are going to learn something new. And for those of you who have, just going to share with you some also, yes, hopefully some new infrastructural ideas. All right, well, so very briefly about me. I did PhD in London, and then worked in Amazon, Microsoft, AWS, now running AI in Toloka. And the whole talk is going to have like 4 parts. We're going to talk about overall philosophy of changing environments and things that change over time in our life, and then how does this actually encompass itself and show itself in the deployed machine learning models. Then we're going to move towards what do we actually build internally for our systems, so kind of sharing experience with you. And then I'm going to move towards actually showing some industry and research use cases which benefit from having such a system, or which just benefit from kind of the human look at them. Well, first of all, about the changing world. I mean, the world changes quite often and a lot, and parts of those changes come from changes in context. When a simple example, where you built a classifier for sentiment of the reviews. And then you wanted to use that classifier to find bad products. And then maybe there was some scented candles, there was a product, and some reviews which indicated that the candles don't have scent actually indicate that probably that product is bad. And before COVID, that was the case. And now after COVID, having candles which don't have a scent doesn't really mean that they're a bad product. Maybe the person was just basically sick at the time. Another situation is emergence of new phenomena. So that encompasses itself in, if you remember, if you actually received any spam mails in the past, they all looked like some Nigerian prince is happy to give you a few $1 million. Just maybe a few hundred you have to send them for the transaction to go through. And now these spam emails, they look much different. They look very similar to how the real person from a real company would write to you. And of course, the old spam classifier is not going to work for the new situation and the new styles of the letters. Now, some of the words have new meanings, and if you were to ask or to Google search something about Tesla 10, 15 years ago, you'd think about Nikola Tesla. And now the majority of searches are, of course, about the company or about the car. So these changes, they, of course, somehow, if you have a model deployed, they somehow translate themselves into the deployed model. So how do they do this? Well, we had a case where a company was building a self-driving system. And they collected a ton of data, and they had really good system. But they were in the prototypes phases, and so they wanted to go to a contest. And the contest was happening sometime in October, and so they were all ready. And then about a week before the contest, what happened was that snow fell, and it completely changed the whole environment. And the models which were deployed, they couldn't, of course, work in that situation. They had to update their models and change things. Now another client had a case with social media classifications. They were collecting a lot of data, a lot of different social media mentionings of their company, and so they had to classify those mentionings into those which are relevant to their company and those which are not. And they had a certain recall and precision requirements. And because they had certain precision and recall requirements, they actually had to send some of those examples to humans for checking. And those are about half of all of the examples they collected, all of the social media mentionings. And after you have some sort of a system, which this is like a hint of what I'm going to talk about today, after you have this system which updates itself, or which actually takes care of model, incorporates the recency into the model, you can really reduce. That's what they did. They reduced the budget. They reduced the amount of money they spend on human labeling. Now, if you think about this fancy new shiny things about GPTs and maybe the great big large language models can avoid these situations, and of course they don't. A simple way to check is you can ask ChatGPT when its training data finished, and the training date for ChatGPT ended in September 2021. And then if you ask something like when was the last earthquake in Turkey, it's going to tell you about the 2021 earthquake in Turkey and not the recent one. Now, so what did we do for to avoid this kind of use case? Because people come to us with the questions of, well, can you build me a model, or can you label me some data? So we did this so-called adaptive models. But the reason why we did this is kind of the heritage of Toloka. So Toloka historically is a data labeling company based on crowdsourcing. And it used to only focus on the crowdsourcing data labeling. Now we have kind of two key components of our product, machine learning models, which are pre-trained and ready to be adapted to the customer use case. And again, the Toloka is like a huge crowd. Actually, it's about 100 countries and I think 40 plus languages. And so those are able to adapt the models to whatever application comes in, whatever language comes in and is needed. And so we produce these human-powered machine learning solutions. We focus a little bit on solutions, of course, a lot on the actual product, so you're able to build those solutions yourself. And what we did internally for these adaptive models is that we thought about the whole process of building a model. And if you think about the process, you collect the data, you clean the data, so all sorts of different steps. And so we said, well, how about we replace the middle part of this process by so-called adaptive models? We did it in a way that now our solution architects who build systems, they only need to, in order to build something, to build it like end-to-end working AI solution, they need to only do the first two steps, which is explain how to label data, explain basically in human language what they need to do, and then the models are like this concept, this internal product is able to take care of itself, take care of retraining and remonitoring at the same time, as the production goes on. All right, how does this work in the background? So if you think about models as a service, then there's a model hosted somewhere. It's getting pinged through the API, and there's a database where the predictions are stored, and the API basically sends some of the examples there. And this is kind of a normal way of doing ML as a service. So what we did is that we added an additional component here, which is, here it's called Toloka project. And Toloka project is a data labeling project, which basically takes the human explanations of how the data instructions, how the data should be labeled, or what you actually need out of every label. And then for every item which gets into the API, some of the items get into Toloka project, then they go to the crowd, and then it's all stored again back into that database. And as you can see, there is this arrow from database to model and back. And the reason why this arrow exists is because some of the model's predictions are stored in the database, but also the data from the database are used to retrain the model, and of course, monitor it at the same time. And we used our normal, whatever everybody uses components for the system. We base our ML things on Azure ML. Then we have Databricks for actually storing the database, and Kubernetes for automatic scaling. Now, what happened in production was actually a curious use case. So that's a story about the same social media monitoring company. And here you can see on the right axis, on the horizontal axis, you have dates, and on the vertical axis you have model performance. So you have this model, increasing accuracy over time very fast until it gets to a point where, okay, well, no more data is really necessary to train it to whatever it can achieve. But then, as you see, the line kind of drops down slowly, and that actually happens because the data becomes more complicated. Kind of the distribution of the changes, but the model still adapts to it. Now, every point is a retraining attempt for like a new event. Right? So a new, maybe like once a day or once a week. Well, in this case, I think it's once a week. No, this is fast. Okay, this is more. This is probably once in 3 days. The retraining happens, and the model evaluates itself, and you put a point there. And you see the point started going down, but the pink line is above. And the reason pink line is above is pink line is the model which is deployed in production, and the dotted line started going down because we introduced a bug in the system. And so we introduced a bug. The model didn't train very well, but the model in production was still performing well. And so, of course, this doesn't really say that the external environment changed and we adapted to it. But what happened is that the system adapted to the internal changes, the fact that the bug was introduced. And I mean, who writes code without bugs? Raise your arm, please. Hand. All right. So basically, what we did, of course, like we tried to think about, all right, now, like where's the place for this sort of a technology? And there are models as a service, things like AWS recognition or Azure content moderation. Those are very cheap, but those are not adapted to the data set that you have at hand. And then the next step people do is, well, right, well, that model doesn't work for me. Let's go to Hugging Face nowadays, and let's just take a Hugging Face model and then train it and then deploy it and then support all the deployments. This is very expensive because you actually need people who know how to do this, and probably not one person. And it's hard to experiment with very many different models. And if you don't build one system, but if you build many systems, it's better to actually pre-build the whole infrastructure, so you have to hire the whole infrastructure team. So we did hire the infrastructure team who built this thing, but we've built this once, and now the solution architects are able to go somewhere in the middle ground here. Well, now let's, I guess, move towards the real situations and industry use cases, and some research ones as well. Well, one of the use cases was content moderation with public messages was provider of actually a public messenger, and they had so-called like public channels where everybody could post things, and some of those things which someone posted were illegal, and the messenger had to filter them out and actually find those bad channels or communities or whatever you want to call them. And they had an internal moderation team, and they didn't really have a model to track this. And they were spending insane amount of money on this, and they were only able to cover like a single language with that internal moderation team. So we've built this thing for them, this solution customized for them with 3 different languages. And what happened was that it ended up in reducing their escalation numbers by 30 to 40%, which is pretty cool. And now, of course, they increase the amount. They are able to scale the volume up. So one of the things which I am, as a, I guess, historically machine learning person, is fascinated with when you use crowdsourcing is this automatic way of scaling things up. When you have like an internal moderation team, it sits. If you have like a good few days, it sits and doesn't really do anything, and then when something bad comes out, I'm being recorded. So when something bad comes out, then what you have to do is you have to hire more people, or you actually have to ask some of your full-time engineers to go and moderate some data, because otherwise your website is overflowing with, or in this case your message is overflowing with the bad messages. But crowdsourcing approach actually allows you to not think about that at all, because the more data you have, the more people just see the task and they come and they execute the task, and you don't think about scaling this up. Now, I like showing this slide because it scares people, and it's not like I like scaring people, but it's kind of the idea of this slide, the only thing which you can probably learn, which you can probably get out of this is human labeling is not like you make a description of the task and you're done. This is not how it works, unfortunately. In order to work with these human creatures, what you need to do is that you need to really explain how to do the task, and then you really need to check that the person is able to do those tasks, and then regularly check that this person still wants to do those tasks well. And also, even then, people make mistakes, so you end up having to ask 3 people maybe for an opinion, and then average their opinion. If there's some sort of majority vote to David Skeen, this happens here. And then if you want like real high accuracy, then in the cases which are very ambiguous, maybe 2 people said this is a cat, 1 person said it's a dog. You feel like it's it's maybe an ambiguous case. Then you need to ask even more people, and maybe like up to 7, and then weigh them out to actually get the right answer. And so this allows you to do what? This allows you to actually reduce. I'm going to talk later about what it really in theory allows you to do. But here, like you have a machine learning model, right? It's confident about some examples, confident about some other examples. In the middle, you send this to humans. But you don't just send it to humans and get great result. I mean, you send this to humans, they agree, and then you get the result, but they disagree, and then you send it to more humans, and then they, hopefully agree. And if all of them disagree, then you basically can manually look at the result and check it out, and see if your instructions are bad or it's just a really weird case. Now another very popular and kind of useful application of the concept of human in the loop is the application of converting handwritten digits or writings into actually not handwritten ones and into the digital ones. And if you take any of the models available out there, none of them are going to give you perfect accuracy. And quite often, in order to get really high accuracy, you need, for the complicated case, you need to ask humans to, in this case, verify what the model is doing. And again, I'm not going to go through the business details, but long story short is you're getting higher accuracy, you're getting faster speeds with crowdsourcing, and higher accuracy than the manual only, than the automatic only recognition. Now this, as I mentioned, there is this process of checking the model which produced something, and that is slightly different than in the moderation case. So in this case, the model actually produces some outputs, and then there is the steps are that you verify the output of the model with humans, and if it's not correct, then only then you correct it. And all of these different things are different small tasks which you need to check. Right? I'm realizing that recording is probably not going to be fun with my head on the right and my microphone on the left, but well, I guess there's some magic with sound which is going to be able to be done. Right. So again, this is what I was telling you is what are the reasons why human oversight here is needed. In very many other cases is you can quite often achieve much higher accuracy than the human-only approach, and you are able to sustain the model performance over time. Now we can move towards research use cases. Those are a little more on the edge, which is where the research is supposed to be. So in this particular case, we tackled the problem of finding the best prompts. I don't know if any of you played with has anyone played with the image generation models like stability, diffusion, those kind of things? Right. Oh, no, okay. So for those of you who haven't played with the image generation models, there's a lot of fun things you can do now on the internet. There are models which are hosted, and you can give them the commands like generate me a landscape or generate me a portrait. And recently, the most recent news is that generate me a portrait of the Pope in a puff jacket, and that actually generated some not very fun controversies, because basically the model was able to generate a really very trustworthy looking picture of the Pope wearing a puff jacket, and like he's wearing this super fancy, very expensive jacket, and of course it was a generated picture, but it was generated controversy that, hey, or maybe he bought it somewhere in Milan or somewhere else. So people started, arguing about those things. And so anyway, but the thing is, to generate really good images, right now, what you need to do is you need to find those prompts, and those prompts are basically like magical words. So maybe you want to generate a portrait of a portrait of a queen, and then what you need to do is you need to put some words, some magical words in the beginning and in the end, so that the image is good. And what are those words? How do you find them? And a natural approach is, you go online and you say, oh, I'm going to take the top words which people use, I'm just going to plug them into the prompt. And what happens is might not be the best approach. So we've designed a different approach to do this. And what we did was that we took a variety of prompts, like all the collection of different keywords which people use for making the prompts, and we've made those sets of keywords from that large set of keywords. And we've designed a task for Tolokers, for human performers, to compare different images with each other, say which of the image they like more, relative to the prompt which was given. So, in the previous case, the task would be, hey, the user gave me the prompt of generating an image of a queen. Which of these two images you like more? So by collecting large amounts of such data, you're able to get feedback on what prompt collections, what keywords work better than other keyword sets. And then we've used genetic algorithm to actually evolve those sets of keywords in order to get like a final set of keywords which works better. And so we found some keywords. This is open research. You can find this on arXiv, and it was I think it was in Europe's workshop last year. So we found some keywords which work better according to humans. So now, what's the idea here, right? Like the idea which I want to kind of pass over here is that human feedback is essential to learn what humans prefer. And if you want to know, like if you want your models to produce something useful, something nice, something pleasant, something aesthetically pleasing, then you might need to adapt those to human preferences, and this is what we basically did here. Now, another one is a task of learning from subjective data, where we've basically, again, this is a pairwise comparison, and we've tried to learn, like, can you actually train a model which says which image of a person looks older or younger than another image, right? And looks older than younger is not like guessing the age. Guessing the age is one thing, and it's actually really hard because you need to guess some sort of a floating point number. But learning which one is older or younger is, again, a subjective task, and so it turns out with these pairwise comparisons you can do that. Now, another thing is, another research application we've done is the application of RLHF, which is now a popular technique for aligning machine learning models. Who heard about RLHF? Okay, well, more people than played with image models. That's good statistics. Right. Well, so RLHF is. So long story short, if you train a large machine learning model, you usually train it on whatever internet data is there, but then it produces some hallucinations, some really totally weird, unreal things. And so in order to make it be more realistic, give answers which make sense to humans, there's a process of alignment called reinforcement learning with human feedback. Now, this is not about this, but this is basically the same kind of idea, is what if you want to design a reward function and you don't know how? You don't know what is a good answer from a model and what is a bad answer from the model. You don't have an obvious judgment out of this, right? In games, when you do reinforcement learning for games, you have a score, and then if the character of a game jumps somewhere and falls into lava, then your score reduces to 0, and so there's a very immediate feedback. Now, In many cases, you don't have such an immediate feedback, many realistic cases. And so what you can do is that you can, and you guessed it, like do side-by-side comparison. So what we did is that we took the OpenAI reinforcement learning agent, and we wanted to make it do a backflip, but without actually training a reward function. And so we've shown to humans video clips, short video clips of this thingy trying to do something, and then asked, which of these is closer to do a backflip. And this way, you basically, we're able to find a policy which makes the agent do a backflip. Well, I've already shared this, but basically, yeah, like the thinking here is that if you want to learn something subjective, if you don't know in your situation a very good definition of what is good and what is bad, ask people to provide you with feedback. Okay, so now this is an important topic nowadays of what's the generative models. Maybe AI is going to take over at some point, and maybe all of this is not going to be needed because you can go and ask GPT. Okay, who heard about GPT? All right. There's just more like I don't know, either someone lives in a cave or is a passive audience. There's two options here. All right, so part of the audience. I want to correct myself. All right, so basically, who can be married? And we've started doing some comparisons. We've done some more comparisons. We haven't published them yet, so I don't want to share them. But so we did it, and we've taken it to a task which is a very simple, popular task for review classification, let's say, and we've got an accuracy of 88 versus 96%. So here, Tolokas are somewhat better. And then we took another classification, which was, I don't actually remember what that specific task was, but was very clear advantage of Tolokas on top of Tolokas versus GPT-3. Now, these slides are not going to give you too much insight, but one of the insight I want to pass here is that GPT models and whatever the models are currently deployed, they're really good to interact with. They're very intuitive. They seem to produce really impressive results, but they're not attentive. They are not really paying attention to whatever task you give it to, and not really exact. And so this is so far the conclusion we've actually made. If you have a very specific task, then so far the humans win, but nobody knows what's going to happen later. All right. But these were classification tasks. Now, one of the important also insights which I should share here is there are tasks like text generation or name identity recognition, like creative tasks, like image generation, right? For those, the models, sometimes do a good job, sometimes not. And what you can do with the human feedback is you can pick the best ones. You can say, okay, well, this one is good, this one is not good. You can say, you can moderate your outputs. If you use them in production, you can moderate your outputs to say that, this is actually appropriate to be on my website or in my support chat and whatever you're implementing, and this is not. Well, that's it. Happy to answer any questions, and it's going to be probably office hours later on. So happy to answer any questions at the office hours as well. Thank you for listening.